Okay, ladies and gentlemen, let's get to it. Welcome to the final week of EECS 494. In fact, this is the last lecture of EECS 494. And we've got a lot to get to today. I hope we don't have to go a bit long, but we'll see what happens. You made it. Congratulations. There are a little over 24 hours until your showcase, okay? This gold is going to be due at 6 p.m. That is 1 hour before our event, our big showcase officially starts. I cannot wait to play your games. They were fantastic last week, and so I can't wait to see how nice they are this week, okay? I will tell you, we've had a few registrations from the EMU teams. Ooh, they are good this year. They are so good this semester. We've got our work cut out for us if we want to hold our title. And so we're going to talk about that. We're going to talk about exhibition and how you can do it well today. We're going to talk about that very briefly. But to be honest, what I want to do right now is I just want to watch your final trailers, okay? You've submitted your final trailers. If you haven't, you're going to get that late penalty. Oh, well, that happens sometimes. So long as you get that thing in before the showcase, you're going to be in good shape, okay? So what I want to do, hopefully we can get to your trailers, we can find them, is I want to watch these trailers. I think we went the normal route last time, so I want to watch them all backward this time. How about that? So all we're going to do, no feedback on this one, unless we really have to say something like audio or something like that. I just want to watch these and enjoy with you, okay? And so we'll watch these, and then when they're finished, a quick little bit of clapping for everyone at home, and yeah, we'll move on, okay? We got Studio 13, Lucky Studio 13, Providence. Oh, maybe itch.io doesn't like us very much. Okay, hold on. Showcase, right? Is that the password? Yeah, all right, Providence. Let's take a look. Providence trailer. Wait, hold on. Am I recording? Yes. Oh, sorry. Yes, I am. Sorry. Okay. Sorry, team. All right, here we go.
The winds whisper people long gone.
I cannot let this stand. Strike that angle. Parry finesse. My blade with precision. By the light of Providence, I rise again.
Providence can help you no more.
All right. Deliciously cheesy, team. Well done. I think the crowd's really going to like it. Very, very good stuff. Okay, well done. Okay, next up. Next up, we have Studio 12. This is Colorbound.
They don't know where they are or how they got here. Only that the colors make things work. Each level brings more questions and more power. And someone is watching, telling them only what they need to know. Crystals, color, inheritance. Why? They don't know. But they keep going. Colorbound is a cooperative puzzle game where color means everything. Change your color. Change your ability. Use your powers to solve challenges together. Think, coordinate, and adapt as the puzzles evolve. The only way forward is together.
Awesome. Very well done. Colorbound. Super, super polished. I'm fairly certain that that vocal announcer is an AI, which, yeah, I'm a little bit spooked for all my my voice actor friends, because it is very, very high quality. And it's clear the team iterated very effectively to make everything a bit clearer, to show the characters a bit earlier. Very good trailer. Fantastic trailer. Studio 11 still getting their trailer in. No worries. We got Studio 10, Night of the Living Ducks. Let's take a look.
What hides in the darkness? What monsters lie below? Tonight is the night of the living ducks. Fight back zombie hordes to protect Mother Duck. Gather bread, build defenses, and gain stronger weapons. Fight stronger enemies. Get more bread, build more defenses. Upgrade your weapons even further. Do your best to survive.
Night of the Living Ducks. Well done, team. Fantastic work. Super cool. I think the little tweaks really help out. The horde of zombie ducks is much more intimidating this time and much more convincing. Well done. Very well done. Okay, Way of the Cards. This is Studio 9.
Trapped in the squishiest dungeon known to Mankind. You'll sling spells, dodge gooey ambushes, and recover your standard cards. Each one of them with your growing magical deck. Will your cast of cards be enough to break free of this wretched place? Rebuild your power, one card at a time, and prepare for the final curtain call in Way of the Cards.
Way of the Cards. Well done, team. Very well done. Again, that intro cinematic, super cool. It's going to get a lot of attention. Shout out to the bald magician here. My kinship with him, I can feel. It's a very relatable character, okay? All right, Studio 8. Let's check this out. Studio 8, we've got Infernal Factor. Let's take a look.
I, Dr. Nuclear. Humanity cannot survive as it is, so you have been chosen to preserve our future.
Control your rockets, fly through the air with nuclear fury. Use your robot body to navigate the environment. Make sure you avoid fire, or you'll get burned. Use nuclear-powered rockets to blast your enemies. Block attacks with a gel halo. Gain energy and unleash devastating abilities. Blast off with Infernal Factor. Nuclear energy is not depicted accurately, and this game should not be taken seriously.
All right, Infernal Factor. Well done, team. And the fantastic little closing shot with the gates closing shut. Very cool stuff. I love the cheesy intro as well with Dr. Nuclear himself. Well done. The crowd at the showcase is going to love it. We got Studio 7, Final Fumes. Let's take a look.
If you're reading this, I'm sorry. The radio, it's your only way out. Follow the signal, it's the only place that's safe. Your car is your lifeline. Scrap is its blood. There's something out there following you. Never stop running. I pray you make it out alive.
Final Fumes. Well done, team. Well done. Very nice atmosphere. It was much easier, I think, this time to hear the speaker. Just fantastic trailer. Very excited to play that one. The challenge for horror games is usually the showcase is very loud, so you're going to want to make sure that you bring headphones, team, and that'll help your experience out a lot. Okay, well done. Studio 6. This is, let's see the title. This is Drawn Together, Pulled Apart.
I feel like I forgot something. Oh, that sucks for you. Oh wait, crap! We have a physics exam tomorrow! We need to study now!
Work with your partner to study for the upcoming physics exam. The power of magnets is at your disposal, but getting an A might not be as easy as it seems. And even when the puzzles seem to draw you apart, know that you're only a simple flip from being pulled together. Remember, not everyone will pass the exam. What grade will you get?
Awesome. Well done, team. Well done, team. We do want that final title card at the very end, like there is at the beginning. But otherwise, fantastic. The music fits a lot better this week. And it just fits the tone of the live action cheesiness, but it also fits the tone of the puzzle gameplay as well. The camera shots on just all these trailers are just vastly improved. Well done. Echo Trace. Let's take a look.
Welcome to Echo Trace, Veralia's magnum opus, a virtual utopia where users can relive the beauty of the past. But even paradise needs maintenance. Join the debug operators, our leading line of defense for system integrity. Traverse the simulation, gather your debug protocols, and neutralize anomalies through Echo Trace's status system. Be careful, anomalies may attempt to...
You should not be here. I've stayed for too long, and it's really got me here. Please, leave.
Echo Trace is expanding. Stability is our promise. Compliance is our pride. Join us today. Your future begins in the past.
Absolutely wonderful, team. Super, super nice pacing and very good timing. I think people will be enjoying the trailer up to this point, and then when this sudden cut happens, it just fills the entire game with so much mystery that people will have to run out and solve that mystery and play the game. Okay, so well done, team. Super well done. I can't wait to play it. All right, we've got Loli the Roly Poly. This is Studio 4. Let's take a look. Very cool itch.io page. If you do have some extra time, teams, all of you, put some time into making that itch.io page look good. People might pick up on it, right? We've had a lot of people and a lot of games kind of get discovered on itch.io. Then they've got like tons of YouTubers playing it, and it's a good time. Okay, let's go ahead and take a look. Sorry for anyone. I got some friends who are like deathly afraid of spiders, so hopefully they make it through this trailer tomorrow. We'll see. Okay.
Separated from her family by a sudden storm and rising river, help Loli, the roly-poly, navigate her way underground to reunite with her family. You must solve puzzles, avoid obstacles, and utilize the environment in unique ways. Gather enough leaves and cross the fierce river. Can you help Loli find her way?
That is so adorably cute. Well done, team. Phenomenal job. It has a great tone. It does a wonderful job of helping you understand what the game is. I'll say at the beginning, in the intro cutscene, there's it looks like it's a bridge, right? But maybe this is just showing that the leaves, they're their thing and they can float. This is so adorable. I love the sweat right here, and the family waited. This is just so nice and wholesome. I cannot wait to play it when we do our grading after the showcase. Okay, P3 Studio 3, Sworn Fish. Here we go. Wow, that's a big itch.io page. My goodness, look at this. I have to zoom out to see it all. All right, here we go. Sworn Fish.
Stories tell of a legendary pirate hell-bent on conquering the seas.
until his will and blade were lost to the depths. But where one legend ends, another begins. Dive into a mysterious ocean. Battle fierce enemies. Gain powerful abilities through the Krill Tree. Conquer the depths in Swanfish.
Spawnfish. That was a pumpin' trailer. Fantastic energy. Despite everything that's going on, the fast-moving footage, all of the enemies and bosses, the rockin' music, it's super easy to follow and easy to understand. Just fantastic, fantastic trailer to be able to accomplish that. The more you pack, the more information you pack into a trailer like this, the more pressure it puts on the team to have a really clear and very articulate organization within the trailer itself. We had a lot of teams just doing a fantastic job. These are great trailers. I think we might have a chance against the EMU teams. We'll see. All right. Okay. Next up, Escape EECS. Very relatable game. We'll be doing that soon.
God, this is so hard. I don't know what is going on. This is like hour 10 at 2 a.m. Wait, what the heck? Hello?
When a late night study session goes awry, a rogue janitor who wants you dead. Find a way to escape. Don't get caught.
Fantastic. You notice at the very beginning, we have the ticking of the clock, and the trailer kind of advances with those ticks. Fantastic polish, and of course, a really nice level of cheese in the trailer. I thought I saw footage of the M-Bus at the very end there for just a brief second, and I can't wait. I can't wait. This is going to be so much fun. All right, well done, team. Very well done. And last up, we have Team 1, Studio 1, Shardbound Shadows. Let's take a look.
You ever wonder what your shadow would do if it didn't have to follow you? In this intricate puzzle platform, I'll make use of your shadow clone and your wits to navigate the obstacles and solve puzzles as you progress through foreboding dungeon levels. You and your shadow interact with the world differently, so swap between as necessary to continue increasingly challenging puzzles. For instance, your shadow could spread its shadow properties to other objects, giving them new properties. Just make sure you are the only one who gets to see the light. Do you have what it takes to light the path forward? Or will you be stuck in the shadows? Find out in Shardbound Shadows.
Shardbound Shadows. Well done, team. Well done. Now, because we're moving so much, we didn't really have a chance to clap for you. I want to reiterate, these are fantastic. Very good trailers for the amount of time that you had. You had no time, okay? You only had like 6 weeks, all right? When you tell that to recruiters, when you tell that to students from other departments, other universities, they won't believe it, okay? The MSU students, you know how much time they get? They get an entire year, okay? Basically 2 months, 2 semesters, so about 8 months, if I recall, to work on their final projects. You get 6 weeks, okay? These are fantastic. These are absolutely fantastic. I have no idea who's going to win the showcase. It's not the most important thing in the world to win the showcase, but I think we got a shot at it, okay? And there are a lot of teams that could take the top prize. We're going to talk more about that in just a moment, but well done. Very, very excited. Okay, some quick announcements. We got an extra credit opportunity tonight, okay? If you're on the edge, or if you are almost at that next kind of grade level, then this could be what puts you over the top, okay? It's also, if you have enough time, I know you're very busy, you're finishing up your own game, but if you have interest in learning more about VR and AR, learning more about Unreal Engine, okay, then the EECS 440 showcase is happening right in here tonight at 7 p.m., and it should be a really, really nice time. It's a much smaller showcase than the one that you have, but it should be a pretty good time nonetheless, okay? You attend, you play a few of these games, take a selfie with that cool headset on, and you get those points, okay? So not too hard. Office hours will be concluding after the showcase, okay? And there won't be, because of the EECS 440 showcase tonight, there won't be any office hours tonight from 6 to 8 p.m., okay? But we'll talk a little bit more about how the end of the semester works. The main thing to know is that after your showcase tomorrow, you have very little to worry about in 494. The only thing you really have to care about is finishing up any of those last extra credit assignments you might want, like the feedback forms and stuff like that. And you have one final postmortem assignment, one final essay to write, but you'll have a lot of time to do that, okay? So don't worry. If you have exams and other course projects you're finishing up, you will have plenty of time to do that, okay? 494 is out of your hair tomorrow at about 10 p.m., okay, when the judging finishes, okay? All right, evals are out now. A quick reminder, that's a way to get extra credit. I think the period for that is ending pretty soon. Every year, we need to know what's wrong with the course. We need to have your ideas on what you want to fix in the course. What ideas you have, that's where we always start when it comes to the summer and making tiny little improvements every semester, okay? So thank you in advance for helping us iterate the course in a similar fashion to how you iterated your games, okay? I really, really appreciate it. Thank you. Okay, what I want to do is I want to finish up our SIMD and GPU programming lecture from last week, okay? It's a really interesting topic, and while you probably didn't have a big chance to implement this knowledge on your game this semester, you should definitely understand what SIMD is and why it matters. Why does GPU programming matter in 2025? Because there's a very good chance if you go to grad school or into industry, you're going to have to do some of that, okay? It's a very different manner of programming. So we're going to talk about that in just a bit. Here's what we're going to implement today, okay? A kind of a wavy kind of image effect in which we basically take the pixels we would normally render, but we put them on the sine curve, okay? And we give them a little bit of whoosh. We tell the UVs that they should be slightly off of where they would normally be, okay? And here's how we're going to kind of set this up. If you ever forget any of this setup, it's very easy to mess up like one tiny part of this setup. It's very nasty and annoying. Once you get it set up, you can just program and experiment, and it's just wonderful. But if you ever want to get this stuff set up, just come back to this lecture and just follow the steps that I do, and you'll get set up in no time, okay? Here's what we're going to do, all right? When a camera finishes rendering, okay, toward the end of the frame, there's one last moment where we can intercept that data. We can intercept that 2D grid of color data, right, representing the final render we're about to show the user. We can intercept that in the form of a render texture, and we can alter it using a material that has a shader, okay? The shader is our logic. The material is how that logic's kind of packaged up with some other assets, okay? I'll show you that in just a bit. Here's the actual shot we're going to have, okay? And here's the final shot we're going to want after we run our shader, run this data through our shader. It's going to look like that, okay? So I'll zoom in a little bit. You can see it a little bit better. We're making the image whooshy, okay? Give it that underwater feel. We can use this for a heat effect. We can also use this for an underwater effect, all right? And so basically what we're going to do is we're going to visit every single pixel, okay? We're not going to do that kind of sequentially. We're going to visit every single pixel at the same time. That's the magic of GPUs and all those cheap, rubbish cores, right? They're cheap, they're crappy, but there's so many of them that we can accomplish simple tasks like rendering pixels to a screen really fast. Okay, we're going to tell each pixel, each UV, it's kind of called, that it should be slightly off of where it was initially meant to be, okay? And we get that whooshiness as a result. Okay, so we can intercept this camera image via a material, a shader on that material where our logic is actually going to be, and the onRenderImage lifecycle function. This is an important lifecycle function that, if it is put onto a component that has an adjacent camera, so a sibling camera component, it basically goes into that camera component and intercepts the information. Okay, it's going to look like this. All right, we're going to have onRenderImage. It provides us a source render texture. It also provides us a destination render texture. This destination is what gets shown to the user. Okay, we're going to use graphics.blit to basically write the source texture into the destination texture, but letting the water screen effect material have at it, okay? So that's how it's gonna go. If this is confusing, yeah, it definitely is, okay? Shader programming is rough, especially when you're getting into it, but in particular, if you end up taking like 298 next semester, then I think it'll feel a little bit better. I've actually got something to show you for 298. Those of you taking it might like this. You get a little spoiler of the very first homework problem in the entire course. I think you'll like it. But, all right, so this is a pretty clumsy process, very error-prone. Just refer back to this footage or recording, and you can just follow it step by step, and we'll get going, okay? Here is the situation, all right? Here's where we're going to start. We got our little objects here. I want to show you real quick. No, not that. I want to show you this right here. This is the final effect. So if I mess all of this up, well, at least we have this, right? And you can see it's working. In fact, this is fairly flexible. You can actually have other objects that can be in front of this effect and not affected by it, okay? We got this kind of whooshy gradient effect, and we got all of our pixels on the screen here just kind of moseying back and forth. This is a screen effect. If I pause the game and focus it, and we look at the scene, you can see that, well, it's not moving. It looks like it's moving, right? The objects aren't moving. We're just playing around with the pixels, that final render. That's all that's happening, okay? And in many games, that's actually how they do it, all right? Okay, let's go into 2025 folder. I want to show you this scene one more time, and then we're going to set this thing up, okay? We got our little scene here. It's not that interesting, okay? Not a whole lot going on. I don't feel that underwater magic. The first thing I'm going to do is I'm actually going to take this main camera and I'm going to go to solid color. I'm going to give us something kind of bluish, okay? Right now, I am slightly more convinced that we're underwater, but not really, okay? This is just kind of that cornflower blue background, not really doing it for me. We need to create a component that is going to intercept this final render right here and let us do things to it, okay? And so I'm going to create a component. Let's call this intercept final render apply water. Okay, what a name, huh? All right. So at Electronic Arts, some of my colleagues really liked super short variable names. I really liked super long ones because the short variable names are always confusing me. I mean, I think that's part of why mathematics is so difficult to get into for so many people. You look at a formula on Wikipedia and you see like a K. Like, what on earth is a K? What is that, right? And you have to go diving through documentation for half an hour to figure out what K actually is, okay? Then you have to remember it, and it takes up it takes up some very valuable short-term memory space while you're doing so. So anyway, I'm not going to do that. Anyway, so we don't actually need either of these functions. What we need is that function I told you about, onRenderImage, okay? And that's why code completion is so nice. You might not even know this function exists, but if you got autocomplete, you're going to find it right then and there. We talked about this idea that we're going to get handed that final render in the form of this render texture called source, but we actually need to write into this render texture called destination. This is the one that is actually going to be shown to the user, okay? And so how are we going to do this? Well, there's a function that's just like purpose-built for what we need. It's graphics.blit. And it has source and destination. That's great, but it has one final parameter that is the magic one. It allows us to provide a material that is going to affect and actually do the transfer from source to image, okay? This is our man in the middle, okay? This material right here. This allows us to get in there and make our changes to that final image. Okay, so we need a material then. Let's call this the water material, okay? And then we can use that material right here. Now, the big problem that we have is that we don't actually have that material. Okay, that thing doesn't exist yet. All right? So you know what I want to do? I want to go in, and we're in this 2025 folder. I'm actually going to drag and move my script in so we don't lose it. Got our materials, got our scene. Visual Studio's freaking out. Okay, great. And if we look at the main camera, that component, oh, did I not make the material public? Yeah, sometimes I wonder, like, how quickly do students spot the bugs before I do? Or how many of you spotted the bug? Like, oh, he's going to need to change that, isn't he? Yeah, you're right. I got, like, 0 sleep last night. I'll show you why. I have a pretty good excuse. I got distracted. Okay, so let's make that public. And by doing that, we're going to get our nice little slot for material, but we don't have a material. So I'm going to create one. Right-click, go to Material. I'm going to call this Water Material 2025. Oh, okay, there we go. And we can see we've got this material right here. Now, a material is just a shader packaged with a bunch of assets. These assets are usually, colors or images, sometimes numbers, okay? But what is a shader? Well, a shader is just an algorithm, okay? Usually it deals with lighting. All right, it's an algorithm that helps the rendering system understand how should light affect my object. For instance, you can see this ball right here. This is the standard shader. It looks like a ball, okay? I mean, this is roughly how things would be lit if they were real objects in the real world. But I can go up to this shader and I can go to unlit. I can go to color. Now you see that this 3D object is rendering like a 2D object. The lighting logic has been dramatically simplified, okay? And so that's the situation here. And what we need is we need to create a new shader, okay? We need to write our own logic. We got a bunch of built-in stuff. Unity gives us tons of built-in stuff, but we need something custom, all right? So I'm going to come down here into my project pane, go to Create, and you'll find that there are just tons of things that you can create. My goodness. I'm going to go to Shader, and in particular, I want an image effect shader. This is a shader that's kind of set up for what we want to do, okay? It's going to have a bunch of stuff inside of it that's going to break your mind, okay? It's a weird language called CG, okay? Has anyone ever heard, you've heard of C, right? In 370, EECS 370, you write C code. Not C++ code, you write some C code. Well, we're about to write some CG code, but this file is actually going to be a Shader Lab file that has some CG code embedded inside of it. So things are already getting crazy, huh? There are multiple new languages you need to learn right here. I'm going to name this shader file. Let's call this Water Image Effect 2025, okay? Okay, it looks like Unity wants to open it. I'm going to double click. Now look at this. We are now looking at our shader. This is our shader right here. Our shader has a name. It's in the hidden category, which means it won't be shown. I'm going to actually change this to 494 2025, okay? And then our actual shader is called Water Image Effect 2025. Now look at all this stuff. Properties, there's a texture, sub-shader. What on earth does that mean? Culling off, Z-write off, Z-test always. Does anyone have any sense of what these things could mean? If you don't know what these things mean, or you can't guess, what it means is you need to take a course on graphics programming, okay? All of these things are very kind of common concepts when it comes to actually rendering things under the hood. There's a fantastic new course, 498 course, upper level CS from Professor Park, which is graphics programming and generative AI. So I encourage you to take that course if you can. Very good choice for game development students to take a course like that. We'll talk about it a little bit in 298. But anyway, you're just looking through here, blah, 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 blah. The hardest thing about shaders, in my opinion, is the amount of new stuff thrown at you, okay? But here's how you can get past it. Ignore things that don't make sense and look for anything that might, okay? We're ignoring all this stuff, blah, 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 blah. We see something here, return 0, that looks like a function, okay? And we have another function just below it, frag. This is the thing that we want, okay? And ignore all this crazy business, okay? What do you see right here? A comment that says just invert the colors. So for now, let's just leave this shader file be. I'm going to go back to my material, okay? Previously, we had all these different shaders we could choose from, but none of them was the water effect that we wanted. When we click on our little box here, our little chooser, our little picker, we can now see that the category 494-2025 exists. We can click on it, and we find our Water Image Effect 2025 shader. If we click on it, nothing happens, okay? Well, I think part of that is that I didn't pull the material in. I got to hook that material up. But now, let's run the game and see if anything happens. See if you notice what happens, okay? What happened here? It looks kind of similar to what it was, but what happened? Yes? We inverted the colors. Imagine that, right? Imagine that. One of the super cool things about programming shaders, once you've got them set up like this, you can actually make changes without restarting the program. Let me show you. I'm going to go in here, and we have right here, it says just invert the colors, but I'm going to actually comment this out so we're not inverting the colors. I save, and we're back to normal, okay? I go and I get rid of that comment, bring back inverted colors, and now we're inverted, okay? It's just that fast. Really, really fun, actually. Now, the most important thing when you're operating in a scary new area, you're in a scary new language, you don't know 100% of what's going on, is to poke it and prod it, and you start to learn what's going on. I would also say AI assistants have made learning all of this way easier. You can actually just copy a line of code and say, hey, I'm in like the CG language. What's going on here, GPT, okay? Anyway, what I'm going to do is I'm going to accidentally put a typo in here, okay? I put the letter A right here, and I save the file. That's a typo, okay? When I come back, I see our favorite shade of pink. What does this shade of pink mean? You ever see it in Unity? What does it mean? It means something is broken or something is missing, right? Again, pink is very common in games, but this shade of pink is not. It's kind of I think many people describe it as a more annoying pink than you usually get. And for that purpose, right, they had to choose some color, so they chose a color that doesn't show up very often in most games, okay? And so we need to try and figure out what is going on in this function. Here is what is happening. A shader takes in data, the GPU, all those GPU cores will run this logic all at the same time, okay? The data coming in, however, will be different. Remember, single instruction set that all of the GPU cores are going to run, but multiple data, i.e. the data that gets fed into the function is going to be different for each pixel, okay? Now, this frag shader, if you don't know what this is basically the shader that takes in pixel data and decides what color should that pixel be, okay? If you look at this other function right here, the vert shader, this takes in vertex data, okay? So if you've got something like a cube right here, right, you're going to get a handful of vertices, maybe in the corners, right? It depends what the underlying geometry is. But this is where you can manipulate the vertices if you want to. And then this information, V2F, is fed in to the frag function. So it's this chain of functions leading into the next function to kind of figure out what that final pixel is going to be, okay? If you're curious what V2F is, it's a data type. And you can actually scroll up here and you'll see it's a terrible name, isn't it? Okay? imagine how much educational time and money was lost to like students look at this and just give up, okay? Because they don't know what on earth this is supposed to mean. If it was like vertex shader to fragment shader package, then maybe people would understand what's going on, right? Took me a long time. Anyway, this V2F struct, right, has a float 2, okay? What is this data type? Anyone know? Yeah, right? It is just basically it's a tuple, okay? It's a pair where each item in the pair is a float. Float, float, float. Would be really great for like an X and a Y, right? A coordinate, right? And this is in fact what it is, okay? It's the UV coordinate. This is basically kind of the XY position on our screen, okay? And so this is how we can figure out where our pixel is. This vertex information, I think, is like where is the pixel, or like in the world, in the scene. Yeah, I don't do a whole lot of this kind of programming. It's been a while. But here's what we need to know. We've got this function frag. It is responsible for outputting what we can tell is a color. We have a fixed 4 color value here. Why is it a fixed 4? Aren't colors RGB? Yeah, it's the alpha. So RGBA, bingo. And why is it fixed? Up here we had float. Down here we have fixed. What does fixed mean? Any idea? Yes?
Constant variation?
Not quite. It's a good idea, though. Fixed refers to precision level. So I believe that fixed is, I think, less precise than floats. I don't entirely recall, but it's one of the choices you could make. We could turn this into float 4 if we wanted to, but we're just going to leave it as is, okay? So right now what's happening is that we're looking up a color, okay? We are grabbing the pixel from main texture, okay? This is a sampler 2D type. It's basically a textured 2D, a 2D texture. We're looking into this final render. We're grabbing the final render, okay? Whatever color we were going to render normally, we're going to grab it, okay? We're going to grab the color at our pixel's position, i.uv. And now once we have that color, we're going to invert it. We're going to take the RGB values and we're going to 1 minus it. Have you ever seen 1 minus, like in mathematical expressions? Have you ever? One of the things that makes math hard is that it has all these little operations that are very common, but they don't look like operations, okay? You've all seen the plus, the addition sign, right? Well, if you go on to further graduate study, you're going to read a lot of papers. Or if you go into industry, you might see this a lot in various expressions. 1 minus, just think of it as the invert operator. When I see 1 minus when I'm reading papers, I see, like, in my head, it just looks like a plus icon, except it's a little invert icon, okay? 1 minus means invert the thing. You're almost certainly inverting something, okay? Anyway, what I want to do, all right, I want to do a test, okay, to verify that this is the way we think it is. I want all of these pixels, no matter what, to be red, okay? What can I do? Well, I'm going to take this col variable that we're returning right here. And you know what? I want to make it like col equals fixed 4. Let's go like, what is R? R, so 255, 0, 0, 255. I forget if it's 1, 0 to 1 or 0 to 255. We're going to find out though. Okay. Look at that. Just like that. Every single pixel is red. Now, let's get a little bit fancier. I want to have some slightly more interesting logic. Okay, this is not going to be very fast logic because if statements, GPU cores don't handle those super quickly. Okay, but we're going to if i.uv is smaller than 0.5, then we're going to make them red. Otherwise, we just go with the normal color. Okay, what are we doing here? Okay, I'm actually going to get rid of the inversion too. This right here is how we check where the pixel is on our screen. These coordinates are not x and y, they're u and v. So they are normalized, from 0 to 1 in both axes on our screen. So let's just kind of see what happens. And it blows up, okay? Let's look at this. What line we blew up on? We blew up on line, hello, 48. Okay, let's look at line 48 right here. Oh, I.UV. I can't compare a scalar value to an x and a y. Okay, this is a 2-tuple, so we can't do this. It doesn't make any sense. I care about vertical stuff. So let's add that and look at that. Do you see what's going on? Okay, the logic is this. If our pixel, okay, if its y position, if it's a v technically position, is smaller than 0.5, so if it's on the bottom half of our screen, then we want to go and make that pixel red. Otherwise, we're just going to kind of let it flow through, and we just get what we normally would get. Yes?
But isn't this shader only applied to that middle white square?
No, this shader is applying to the entire final image. Okay? So if you look at, that's a very good question. If you look in this scene right now, this cube has a material on it. Okay? If you open up the little material span, default material. Now the default material is just running the standard shader. Okay? So is this yellow pill right here. It's running the maze material. And if you look at the maze material, it is using the standard shader. Okay? It's not using our water shader. So all of these objects have their own material that gets to process things and deal with lighting and make their object look interesting. But then at the very end, our main camera has a material as well, which is taking that render, which would look like this, right? Like this, and it's changing it. It's going through every pixel. It's sicking the GPU on every pixel, and that GPU is running the logic that is in the shader that is on this material. Look at this material, right? You can even see kind of how the shader is going to do its thing. Okay, which is kind of neat. Okay, well, this is cool and all, but I want underwater effect, okay? Where is that awesome underwater effect? Well, we need to go do some stuff, okay? The first thing I'm thinking about is let's just go back to normal. Let's just get a kind of a normal look. There we go. It looks great, okay? Now, what I want to do is I want to get our pixels just kind of going back and forth, right? That's a huge part of the effect that we want. And so how are we going to do this? Well, this function right here is the key, text2d. Right now, we're grabbing our pixel's color in a very standard way, right? This is that texture kind of coming through after the rendering of the scene is finished, and this is the position our pixel is in. That's the UV position of our pixel. But who's to say that our pixel doesn't kind of cheat, okay? Because here's what I'm thinking, okay? Here's what I'm thinking. I want to have an offset. Let's go fixed 2. I'm going to call this pixel offset, and I'm going to make it fixed 2. Let's like get our pixels grabbing the data from the ones like next to them, like to the right, okay? So let's go like 0.1 and 0. This is kind of like a little bump, a little offset we're gonna add on to our actual location, okay? And hopefully that makes some sense here. And let's go see what happens. Wait a second, I feel like something has changed. Something tiny has changed. Okay, wait a second, let me, if you didn't notice the change, let me just go ahead and make this a little bit more noticeable. Okay, have you noticed anything? All right. So our camera has not changed its location. Okay, this is the image that's coming into the camera. Everything's nice and centered. But what we've done was we basically told all of our pixels that you should grab the data like to the right of you. Okay. So the pixels in the center are actually grabbing the data from over here, and so there's nothing in the center. The pixels over here are grabbing data from the center, which is why we see things over there now, okay? The pixels are stealing each other's data, and this is allowing us to move. Now, we are not moving over time, though, okay? And that kind of stinks, all right? So there are a couple things you just kind of got to know in here, which is a bit frustrating, okay? You can use something called, I think, sine time.x. Is that right? Let's go. Shader lab, sine time. Oh my gosh, yeah, I think I got it right. Whoa, all right, let's try it out and see what happens. Yeah, I don't see anything. Oh, I'm gonna unpause the game and look at that. Our objects are moving, okay? Now, sine time, this is going way too slow, okay? I can barely tell what's going on here. Okay, this is going way too slow, so I want to multiply this by like 10, all right? Okay, we have lost our object here. It's gone completely, and what I'm wondering here is maybe I need to make this smaller. Okay, let's make this a little bit smaller. Well, let's make it faster, okay? Faster, 100, 100, okay? And it's gone. Let's go 0.5. I'm just making this smaller and smaller. Okay, it's going back and forth, back and forth. I think I can actually make this fall. You know what I want to do? I want to do this. I want to take it manually. Let's go sine of time.x, and I want to multiply this by 100, okay? I saw some smiles. I'm guessing you noticed that my algebra is canceling itself out, right? So I'm getting nowhere. But this will help us actually get somewhere. Let's go like this, okay? I think that's going to be better. Oh, nope. Sine times 2, sine of time. I forgot my underscore. You can't forget your underscore, okay? Look at that. There we go, okay? Now, to tell you what's going on here really quick, because we're running low on time, this time object right here is just a global you can use, and it will advance. It will advance constantly, but you see, it's a struct. For whatever reason, it's not a number, it's actually just a struct, so you need to do .x or .y or .z to actually get a number, a float, a scalar that advances as time goes on, okay? This is really fantastic stuff. This is a really good start, okay? I can make this number even bigger, and we can go crazy like this. But you know what I actually want to do, okay? What I actually want to do, we don't really want this because this doesn't look like you're underwater, right? The problem is this. Our pixels are moving back and forth on the sine wave, which is what we want. But in order to get that whooshy effect, right, our pixels need to be at different positions on the sine wave. At any given moment, some of our pixels should be in like a downward trend on the sine wave, and some should be in the upward trend, right? That'll give us the whooshy effect. So what can we do? Well, we can do this, okay? This offset right here, right? This offset needs to be adjusted, okay? Our position on the sine wave, which is determined right here, needs to be adjusted by the y position, the vertical position of our pixel. So we can do that by going I.uv.y, okay? By the way, when you're dealing with sine waves, if you haven't done much trig lately, this is like, what are you doing, Austin? This is crazy black magic, right? If you ever alter the thing inside the sine function, you're adjusting your location on the sine wave, or you're adjusting how quickly you go through the sine wave, right? If you do anything to the exterior, like this 0.2 here, you're adjusting the magnitude of that wave, the heaviness, the size of that wave, okay? Well, let's go ahead and look at this. Look at that. Wow. That's pretty cool, isn't it? Right? Now we actually have an effect that you could not do with just normal C# programming. You could not do that. Now, I can make this even more intense by making our offset bigger, okay? Let's multiply this by 10. Oh my goodness, this is ridiculous. Now, my recommendation is whenever you get a number that's working, you have to make that number as big as you possibly can. Of course, right? Look at this. We have a crazy screen effect here. Now, I'll say that this looks kind of retro, but I'm not a huge fan. I want to actually make this tasteful. And so let's slow things down a little bit. I want to have less movement overall, and I want to make it less fast. Let's see what's going on. Ooh, that's cool. This is like a crazy TV signal coming in. One thing I want to point out to you, and I'll see if I can do this. I want to create another variable here, okay? I'm going to create a variable. The reason it's called CG is because it's the C language that's been had a bunch of graphics programming, keywords and stuff, and data types bolted onto it. So you can do things like just write a float here. I'm going to call this craziness. And actually, I'm going to call this waviness. No, I should call this frequency. Okay? Okay, currently our frequency factor right here is 100. Okay, so I actually want this to be like 10, so it's not completely crazy. Let's see how 10 looks. Okay, let's see how that looks. Okay, yeah, that's not completely crazy. Let's go and plug in frequency right here. Okay, what I want to do now is I want to expose this variable. That's what Unity is all about, right? Yes?
Sorry, how do you think frequencies that you're multiplying the time x by?
Oh, yes, you're right.
Your like, phase offset.
Yeah, so this really would be better as like whooshiness.
Yeah.
Okay, so I'm going to put that in here. We could make that a variable as well, but we just don't have time. So if I recall, what you can do is you can actually come up here. This properties pane, this is not CG code, okay? CG code begins with a CG program keyword. This is all Shader Lab, which is kind of the interface between Unity and CG. This is where we can put new variables. I'm going to call this whooshiness factor, okay? Actually, no, I'm just going to call it whooshiness. I think we need to call it that. I'm going to make this float. I hope this is okay. And we want it to start as, what was the value we were using? 10? Okay, let's do that. Hopefully, this doesn't explode. And let's actually go ahead and end this right here. I'm going to go to this material, water material, and look at that. We've got a float right here. We've got a float, so I named it the wrong thing. I think this should be called whooshiness. All right. And there we go, whooshiness. I'm going to play our game. And now on the material, we have this property that I can just click and drag and edit as much as I want. Okay. So here's the use case. Once you get it showing up on the material, you can actually, from C#, you can actually go in and you can actually alter it yourself. So we could go to waterMaterial.setFloat and say, I want to set my whooshiness float to like 999. Or you could write a coroutine that causes it to go up and get really whooshy and then kind of come back and get not whooshy. Why would you want to do this? Scene transition. Imagine like a Star Trek style of game where you step onto the teleporter pad to finish the level and start going, woo, right? It goes all crazy and then change scene and then you go back from whooshiness. And you've just created a really, really cool transition effect that almost no other student team is going to have, right? Yes?
Would that involve having an object like the camera persist across scenes? Or do you have like a whoosh and unwhoosh?
You probably would want the camera to persist across scenes. Yeah, that's the easiest approach. But you could have another camera that just renders to the same render texture, and that's another way you could do it as well. But I would just have the camera persist. That's going to be the easiest way by a mile, I think. In any case, we now have this ability to make cool, whooshy stuff happen. So I don't know. I kind of like this, kind of lava lampy, I guess. And let's stick with 4.39. I think 4.39 is a really good value. So let's stick with that. What I want to do now is I want to do one final thing. I want this to begin to look more blue as we go down. One of the things about being underwater is that the lower you go in the water, the kind of less light can reach down that low. Okay, more light is kind of knocked away. And so I want these pixels to kind of get more blue as we go down the screen, okay? So how can we do this? Well, our cull right here, okay, is the color we're currently, the pixel that we want to render. But I've got another pixel that I'm thinking about. Let's call this fixed 4. Let's call this blue pixel. And I'm going to create a new fixed 4. That's going to be R, so that's 0, G, 0, B, we want all the B, all that blue, and then we want the alpha as well, okay? So this is our blue pixel, and we could just render everything as being the blue pixel. Let's make sure this works and good, looks exactly what we want. But what I really want is I want to lerp, I want to mix between these two pixels, okay? So we can get a final color here. I'm going to call this final color, okay? I think we can do a lerp right here. That's the function. I want to lerp between our color, our normal pixel, and that blue pixel. And I want to that final value to be related to our pixel's vertical position. Now we're going to take a look at this and something's going to be wrong. I didn't expect this to be wrong though. Let's see here. Oh yeah, this is not a variable. So we can't return that. We can return our final color though, okay? Now this actually I think looks really cool, but there's kind of a problem here. We got it backward, okay? At the top, we have the darkest, most blue pixel, and at the bottom, things are becoming more normal. So what did we do? Well, we made a mistake. How can we fix it though? We can invert this value. Do you remember that operation? 1 minus, okay? Just like that. And let's see if this fixes it. Bingo. Looking good, okay? Is this cool or what? You can do all these fun experiments with graphics programming. And remember, the basic idea of SIMD is that you're going to have 1,000 cores running the same instructions, but you want each core to do something slightly different, right? How can we make each core on our GPU do something different if they all have to run the same logic? Well, that logic can go down different paths and do different things based on the input data, because that's what's different. A single algorithm, but multiple data getting pushed in, right? Single instruction, multiple data, SIMD. All right, it is the way of the future. It is the way that GPUs work. It is how you program things when you need just massively parallel computation, okay? And it's super fun too. It's very artistic, but you do have to start thinking about images as not just pretty pictures, okay? No, this image is a 2D grid of pixel data, and a pixel data is RGB. That's 4 floats, okay? And if you start thinking about it that way, you can do all sorts of amazing things. The biggest problem with all of this is just you need a material, you need a C# script, you need a shader lab, you need a CG inside of it. There's so many weird things you need to set up, and most people give up during the setup, okay? And the last thing I'll say, and then I'll answer your question, is when you program shaders today, most people will use a tool like Shader Graph, okay? In Unreal Engine, you've got like a nice shader graph style material editor as well. You even have something like this in Blender. But you should know what SIMD programming is in the event you need to write it in a textual fashion, as you often need to do. If you're ever writing language, CUDA, right? CUDA language for NVIDIA GPUs, right? People use GPU code to do computation, just general purpose computation. Mathematics, physics engines, stuff like that these days. For quite a while, GPUs were only about rendering. But then people realized, right, they started to think, wait a second, this really isn't about pretty pictures. What if you can pack a bunch of calculations into each pixel, right? And you can then get a result texture, and then you read the texture to get the answer to all your calculations. You could do a ton of math unrelated to graphics by using GPUs? And the answer is yes, you can absolutely do that. And a big area of research today is how do we take really important problems like pathfinding and find new algorithms that allow a GPU to solve these formerly CPU-only problems and to solve them much faster. So, right, machine learning is now done on GPUs. They were able to crack that code, okay? And so it's a really interesting and very exciting time if this kind of programming resonates with you. All right. It's also really pretty and very interactive and very artistically pleasing thing to do. Okay, question?
How easy is it to like accidentally brick your game with these shaders?
Brick your game?
Yeah.
How? How would you brick your game?
Making like I don't know, too many nested if statements, and then the shader like takes
Oh.
a year to actually load.
What'll happen is your GPU, I think, eventually gives up, and it just goes pink screen. So I don't think I've ever bricked Unity writing shader stuff. But if you did, what you could do is you could just force quit Unity or turn off the machine, right? And then you load in. Before running Unity, you go edit your shader script, right, to make it normal. And then you should be able to get back. So you should be fine. Okay, question?
And then in this case, you have this material directly on the camera.
Yep.
How hard is it to like either change out materials on like dynamically?
Should be really easy. Yeah. Should be super easy. Basically, the only thing we're changing here is we need to change the material that this variable refers to. And it'll get fed into, the final render will come in here, and the final render will get fed into water material, and the output of the material will get sent to the user. So just changing what material you send through graphics.blit will change what shows up on the screen. Yes?
Okay. And then in this situation, you have like the wishiness factor. Would you have a separate coroutine in like some other location that like scales wishes up and down?
Yeah, probably. Yep, probably. All right, cool. Very good. Any other comments, questions, real quick? Yep.
The wishiness.
Yeah.
Stuff, it's only it's relative to the camera view, right? Not like the world space.
Yes.
If you were to put something outside of the camera view, it wouldn't show up.
Exactly. If I put another object, let's do this actually. I'm curious. So let's put another pill right off the screen here. Okay, and let's play the game and see what happens. Okay, that whooshiness should cause some of the pixels to come in from that other object, right? But no, because that data doesn't exist at all. Okay, it isn't in the camera view, and so no pixels are ever going to get picked up. If I move it over here, suddenly it starts to come in, right? Because that information is now there. But it's being culled, basically. If it's outside the camera frustum too far, it gets culled, and we never consider any of that pixel data from that object, okay? So that really, if you understand why that's happening, then you've got a good feel for what's actually going on under the hood here, all right? In any case, all this code, you can download the project if you want. I think it's on the agenda, and I think it's also in the course repository if it's curious and interesting to you. When I was learning this stuff, I didn't have AI assistants to help, so it was just a nightmare. You should be able to learn it much faster. Okay, I want to talk to you a little bit about exhibition, and then I want to talk to you about showcase logistics, and then a final talk. We're going to take a really quick 5-minute break right now, and then we're going to just charge through the rest of the material. I have a gift for you at the very end of this lecture, okay? So we need to make it to the end of this lecture for sure. Okay, I'm going to see you in 5 minutes, all right? 5 minutes, and then we speed run it to the finish. Okay, everyone, we're back into it. I've got a couple things that I want to talk to you about when it comes to showcasing your game. Okay, tomorrow, the question of how you construct your booth is a really important one. How many people will play your games? How many stations will you have is maybe the biggest. Okay, you can bring laptops, you can bring whatever, you can plug into monitors. But you want to have as many people playing at the same time as you can. That helps throughput. It helps you get more votes, okay? But there are some other things as well, all right? Shout out to my dad waving in the middle here of the photo. Booth height is one of the most important things for getting attention from across a busy crowd, okay? I want to show you this phenomenal talk that goes kind of into a bit of this. Height is important. And if you can get your banner, okay, if you can get a poster, if you can get a logo, anything up higher, okay, then people will see your stuff and they'll want to go to you, okay? Let's take a look at this.
Now, you're at the event. What do you do first? You build your booth. And when it comes to building booths, height is very important. This was an overnight booth at Gamescom, and you can see that is Move or Die because we had a big banner saying Move or Die. And next to us, there was a very cool game called Epistory, because you can see the banner. But next to them was another cool game that I cannot name because I cannot see their banner. So height is super important, and that's why you see. That's why these are the things you see when you first walk into a venue. These huge banners, and that's why they're on the ceiling. Because height is at a premium, and the higher you get your print, the better. And here's a weird setup I had at one of the events where I put a screen really high, and that was super cool for spectators to just watch the game from a distance. A quick way of doing this, and a cheap one, is to get balloons that spell out the name of your game, and you don't have to worry about, I don't know, getting them too high because they do that on their own. Sound is also very important because you're basically surrounded by super loud companies, and the reason why you're here is to get players' attention, and you can do this very easily by using sound. And you might think that the speaker might be too loud when you test it on your own, but I can assure you it's not loud enough, because it's a different thing when you test it on your own and when you test it with a huge crowd surrounding it, completely occluding the sound.
Yes, so speakers are definitely something you want to think about as well. Projecting sound, super good idea. And if you have an experience where sound is critical, you probably want to have at least a station or two with headphones, okay? So that people can enjoy it. But you definitely want to have at least one station with speakers to pull people in using the sound, okay? Here's another really interesting thing. You want to grab attention. How can you do this?
But they have a surprisingly short time frame when it comes to grabbing their attention. And I was thinking how I can show this in a very interesting way. So what I did is, at an event that I was showcasing Move or Die at, I just stepped away from my booth and I was recording random people walking by my booth, and then I edited that footage and I added a number above their head representing the number of seconds they were looking at my booth, and you end up with something like this. And this took a lot of time to edit. As you can see, in this case, we're under 5 seconds. So that's a very small time frame. Here's a different one. He was just walking by, they see my booth. He was checking his phone a little bit, looking at the booth a bit more. And yeah, that's under 10 seconds. That's 10 seconds. And this is the last one, and it's my favorite. Some girls were passing by, they were looking at the booth, and I was panning to show the booth, and then back to them, and they're gone. And I couldn't even set this up if I wanted to. So yeah, you have a super short time frame to get their attention, and you have to give them something to do. So what we did is we made these prints of character outlines, and we encouraged people to draw their own characters. And if they took a photo of it and posted it on social media, they had a chance of winning a free Steam key for the game.
Right. So there are lots of ways to attract attention, right? Getting stuff up high is good. Audio attracts attention. Also, little things like business cards, right, can attract attention and keep people kind of engaging with you even after they leave. Maybe they don't have time to play it then and there, but they'll take it home and remember it if you give them something like a business card, okay, or a giveaway or something like that. All right. What else? Another couple of interesting things here, okay, that happen at the 494 showcase all the time. Okay, yeah, height, blah 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 blah. Okay. By the way, there are lots of big monitors just scattered around North Campus, the BBB. Okay, like if you find them and wheel them over to your spot, you can have really, really good hardware, beautiful big screen that other teams don't have. You show up early, you get access to the best stuff. By the way, if you show up early, you get access to the best tables, because not all the tables are positioned equally. Some of them are kind of hidden in the corner. You probably don't want those if you want to have a lot of people playing your game. Some of the tables will be reserved for EMU, okay? And so they tend to show up a bit later, and so we don't want them to get burned and put in the corner. So your team wants to show up early if you want to get a good table, right? Audio, really important stuff, all that good stuff. Attention-grabbing things, lights, banners, okay? Clothing is a huge one, okay? Clothing, giveaways, cards. Okay, you can see at this table right here, this team has a cool little character that's kind of themed and related to their game. And so that really helped out. People see it, they want to walk up and they want to play and try it out, okay? You can see over here, right, the characters, the marshmallow characters, put on a table behind the booth to elevate them so everyone could see them from across the entire room, okay? Super cool stuff. This team even brought in a projector, actually, so they could get it even higher up. This team, right, this is kind of a slapdash setup, but it worked super well. Good for this team. They basically found like a digital board and said, we can't really use the digital board, but we can use it to tape our poster up and get it elevated. And they made like a research-style poster, which is kind of funny, okay? We should have easels there, so this kind of thing can work, okay? Not a terrible idea. This one was awesome, okay? You get the experience of being in a, Cowboys versus Ninja battle, which this game is about, before you even touch the controller. While you're waiting in line, you get to enjoy the cool costuming that the team put on for you. And it's just a really, really fantastic idea. So if you can get your team in some sort of attire, right, make it look like the team is actually a team, you got a bit of a uniform going on, it's themed, that really, really tends to help at the showcase. At some showcases, like the research showcase today, you'll see all the students in suits, okay? At our showcase, you tend to see them in much funnier and more entertaining things than business suits, okay? This game was themed around, like, teachers, okay? Like primary school students, okay? And so the team dressed up with, like, the kind of classic kind of teacherly hairdos and attire. This team had a game all about construction. It was like a wrecking crew game where you flung around these wrecking balls to destroy stuff. And so the entire team went out and found hard hats, and I think some of them even wore jackets that kind of had that industrial feel to them. Okay? So super cool stuff. Blah, 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 blah. Yep, the marshmallows elevated up. There are a lot of really nice, tall, thin tables in the Beister building. Grab those, wheel them behind your booth, and you have a lot of room to work with now. Okay, a lot of cool things you can do. And yeah, it can get pretty busy, but know that you can do stuff behind your booth as well. Behind the booth is actually a good place to put additional stations. So you don't want to have a line. Okay? What is the optimal situation to have at your booth? If you see a big line for your game, it's gonna really boost your ego, right? But it's not gonna boost your chances to win. Because if they're in line, they're not playing, which means they're not gonna vote for you until they do play. So the optimal situation is to have no line, but every station is full. And the moment a station is empty, someone walks up or you beckon them over and they fill the station, so you are going 100% of the time and no one's waiting. Okay, yes?
How many players do you say on average people have at their stations? How many is the most?
Oh, it's wildly varying. Some teams don't take any of this advice and they show up with one laptop and nothing else. And they don't get a whole lot of votes. Not a whole lot of people play their game. Their game could be amazing, but people won't know. Okay, especially if it's a single player game that's long, because you'll have one person hogging the entire game for 30 minutes straight, 40 minutes straight, okay? And that's really scary. So you want to have a lot of throughput, especially for those longer single-player games. And yeah, okay. Here's a good one. This is just kind of somewhere in the Beister building is just this roving TV. And if you can find this thing, this is a really good one to grab for your team. This team was especially smart. They found some rulers just around the building. They had some duct tape, and so they taped it, and they were able to make an even taller kind of area where they could suspend their sign, and so it was just fantastic, okay? This team, I think they might have won their showcase. They also all wore these nice beards and flannel and bald caps, right? I don't need a bald cap. And they took their wrenches. This is Scrappy Pappies, right? They were the characters in their game, and they also spoke to people as if they were old. With kind of an old accent, and it was very fun, okay? This team right here was very clever. They brought little stickers to give away, which was super fun, and they also put their characters up on the actual stairwell, okay? So super fancy and very nice. The important thing here is that you do not use packing tape. Use painter's tape. Use the tape that is easy to pull off. Otherwise, Steve, the facilities manager, is going to come and kick your butts. He'll kick my butt, and then I have to come kick your butt, okay? So don't do that. Okay, you can see here a lot of easels have been put up on tables behind the booth so that they can be seen easily from across the showcase, okay? If you want to guarantee something, you have to bring it, okay? Because maybe you get here a bit late and everything's taken. Maybe some equipment you requested couldn't be delivered, okay? But if you do bring something of yours, please be careful. Keep your eye on it, okay? Just to make sure there's no theft, all right? And yep, putting stuff up at the top. We just had a team that was themed around ducks and bread. They actually brought a toaster and they were making bread for players to thank them for coming up to the booth. I've never seen something like that. They have the little ducks at the top of the screen, okay? It was a good time. Very, very good time. All right. Costuming, really good. You've got a water-based game. Okay, good. You've got a wizard game. Okay, so it's kind of a low effort, but you like the low effort, right? And this is a very high effort kind of construction, get up, head and body. Okay. And yeah, there you go. Blah, 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 blah. Anything else to do? No, I don't think so. Make sure your game works so you don't end up like Phil Fish. I showed you what happened to him not too long ago, right? Hey, this is what I looked like when I had hair, except not too much of it, right? You can see right there a little bit. And there you go. Anyone have any questions or comments? All right. Good. Good. Remember, the experience begins before you even touch the controller, okay? So make sure yours is going to be a good one. Make sure people want to rush out and play your game, okay? So that's all I've got to say about that particular topic. What do we have next? Really quickly, as you finish up your final projects, students often underestimate the appeal they can have, okay? So some teams enjoy going and submitting their games to showcases and festivals like IndieCade, okay? If you submit your game, there's a chance it might win a Student Game Award, and that is a huge boon for your resume. You can then call yourself an award-winning, right, game dev, even if it's just a student award, okay? And so many of these competitions are out there, and they usually only require kind of a short application, and usually like an application fee like $25, okay, which you can split among the team. In any case, if you do not apply, you will not win, okay? And one of the cool things I learned was that very few teams apply. Very few teams apply. Gentlemen, thank you. Very few teams apply because they assume they won't win, all right? And so you end up with less competition than you realize if you apply to these things. If you can get into the habit of doing so, if you can create the assets like a trailer that you know you're going to need, okay? That makes applications very fast, all right? What's more, if you want to continue working on these games, it is possible, okay? We had the famous Yoked game that went out and signed a 5-figure deal to get their game finished on Steam and then put onto the game consoles. You can read about that there. Temporal terror, horror games in particular, do really well on itch. And they had some YouTubers like play the game and get tens of thousands of views, which is pretty cool. In any case, if you want to try and take your game further, it's kind of a tough road, but we did put together a guide to help you figure out what you want to do, okay? If you want to go out and get a publisher, you usually need to hire some professional artwork, and you usually need to, email them. You need to have a pitch deck ready for presenting to them. Here's like an example from Yoked. It's not going to fully load in, but you can go to this later if you want to. You can actually use theirs as a template if you want. They've given permission. And I've prepared a spreadsheet for you. Here are all of the small indie publishers that I know about. Hitsense.com is the one that published Yoked and worked for our previous 494 game. Rodalika Games did the Sagebrush, a local community member, got them went with them. And that worked out. Devolver Digital, a super huge one. You get them to publish your game, you're going to make several $1 million at least. That's basically a guarantee. Chucklefish of Stardew Valley fame. Okay, you got a cozy game. Might be a good idea to reach out to them. But there's just a lot of teams. There's my publisher, Pineapple Works. Okay, there are all sorts of stuff. Finji, which is on the west side of our state. So anyway, basically what you do is you make a copy of this spreadsheet and you email all of them and you hope that a couple come back. So the team that did Yoked, they applied to like 40 different publishers. They got interviews with like 10 of them. They got offers from like 2 of them. Okay? And that's just how it goes. It's just a lot of sweat equity you got to put in. Anyway, you've got a lot of help here to kind of guide you through that if you want to. Okay, let's talk about showcase logistics, and then let's finish this semester up. Okay, let's talk about what this is going to be like. All right, showcases have gotten pretty big lately, and we're going to have about 20 teams, and so this is basically how it's going to be. We got this kind of aisle-based shape, but then one of the aisle on the left side kind of turns into a T. We've got some games back there too. You do not want to be back there. Okay, back there is okay. You'll get plenty of traffic, as you can see, but the best booths tend to be prominently on the side of the hallways around here. Okay, so that's really kind of what you want. The schedule, okay? We advertise the event is beginning at 7. That is when things are going to show up. Now, this is actually a bit different this year. We're probably going to start trailers at 7:30. People start to show up at 7. They'll have some timed player games. We'll get the trailers rolling and the intro going at 7:30. We push everyone in the Beister building. But then after that, you'll have a big block until about 9:45 or so of exhibition and voting. This timeline is all messed up, okay? All messed up. But basically, you'll have a big block of around 2 hours after the intro presentation where everyone's voting, running around. People will vote by going to the website, 494showcase.com. I'll have some QR codes everywhere. You get to vote too, by the way, and you should vote for your team unless you don't like your game. Okay? And everyone will go to the website and vote and have a good time doing that. Around 9:45 to 10 p.m., we'll actually announce the voting results, and you'll all get to claim your prizes. Okay? From 6 to 7 p.m., right? 7 is when the attendees show up, but 6 is when you show up, okay? This is like the latest you should show up. I recommend getting here a bit earlier. Try and get one member of your team to show up a bit early so you can claim a good table and start to kind of scrounge up resources around the building, okay, before everyone takes all the good monitors and stuff. Please eat before the event. There will be no food at the event itself. This is what voting looks like. You have this Google form, and you fill it out. You get to choose, I think, your favorite 5 to 7 games, and everyone gets to do that, okay? I will say it is a strategy to invite as many friends and family as you can, okay? Because they tend to be a bit biased for you, but they will also have to vote for other teams as well. By the way, this brings up a good point. What grade do you get if you get first place? Come on, let's go. We don't have much time.
Same grade you would otherwise?
Yeah, the same grade you would have. But what grade do you get if you get last place in the showcase?
Same grade.
Exactly. Okay, the showcase does not affect your grade so long as you're there, okay? You aren't allowed to miss the showcase unless you get permission. It is required attendance. Send us an email if something is blocking you. But this showcase is just for fun, and some games are not designed to win a popularity contest at a darn noisy, loud expo like this, okay? If you have a horror-based single-player game, God help you, all right? Because this is probably the worst possible atmosphere for a lengthy puzzle-based horror game, okay? It's just super hard to win. The games that tend to win tend to be quick multiplayer games because they have amazing throughput. Lots of people can play them at once. And they are very quick, so they get lots of throughput, okay? That's simply how it goes at an event like this. So this is to say ahead of time that don't be sad, well, be a little bit sad, but not super sad if you don't place super well in this showcase. Some games are simply not made for it, okay? But do the best you can to give your players a good time. And let the die land as they may, you might end up doing better than you think, okay? We do have single-player games win from time to time. Last semester, single-player game, 2 semesters ago, single-player game won, okay? The prizes basically look like this. They're a bunch of codes from Humble Bundle that basically you get to pick up off a table. At the very end of the night, there's a big table with a bunch of codes on it, like 50 codes for 50 games, and you get to walk up in the order you place. So I announce what the first place team is, and the first place team gets to walk up and grab the prizes they want from the table. Okay, if you are like the 8th place team, you're just grabbing whatever's still available. Okay, you're going to get some weird game you've never heard of. We got some pretty good games this year, but you're going to have to wait until we roll them out on the table to see which ones are available. Okay? A couple things. Do not claim more than one exhibition table. Okay? Don't even look like you're claiming it. Go, put everything you got on one table. All right? Otherwise, I'll tell you to move and make it clear because people always do this, and then there aren't enough tables, but there are. It just doesn't look like there are enough tables, and it's really weird. Okay? Do not move any of the tables. They have been strategically placed to protect power outlets and stuff like that. Don't place anything in the area where people walk. Otherwise, we'll force you to move it because there's not a whole lot of room when you get a really busy event like this. Yeah, you can do whatever you want with the space behind your table, though. You can even have additional stations back there, and you just have people walk around to play it. If you see a big E on a table, you are not allowed to take that table. It's an Eastern Michigan team. I have to reserve some good tables for the EMU students because they tend to arrive a bit later, and they end up shoved in the corner, which is not good. It's not friendly, all right? And do not use any tape except for painter's tape, okay? Painter's tape is the only tape will allow you to actually put on walls and pillars. Why? Because it's really easy to get up, okay? I might, but I might also not have tape for you to use at the actual event itself, okay? The final grading schedule is this. We're going to start grading around 1 week after the showcase is done. Once all of the grades are entered and your final grade is visible on the canvas, we'll announce that fact. 24 hours later, we will submit and finalize your grade. There's really no changing your grades after that, so we'll ask you to look and make sure all the regrades have gotten finished. There are a bunch of regrades that I haven't had time to do yet. I've got them all, and I'm going to go do them after the showcase is done, but not until then. Okay, anyway, quick talk about grade grubbing, okay? Do not request special, unusual, or any emotional consideration of grade adjustments. Do not say, Professor Yarger, we got to meet in person. We got to have a Zoom, okay? If you have any requests relating to your grade, like I missed something, or, there's some points I forgot to grade or something, you send that via email. It's very hard to emotionally manipulate someone via raw text, okay? So that's how you're going to do it. Otherwise, I'm just going to ignore you. All right? Do contact the staff as soon as possible with a detailed description of any non-subjective grading mishaps, like we forgot to grade something, or we didn't get to a grade request, or whatever. Okay? Do not request a grade bump because it will help you graduate, or because you feel like you deserve it, or you're really close. Okay? The time for grabbing those extra points is in the past, and you should have gone for them. Do not request to meet in person or have a quick call to explain everything, all right? I do not want a timeshare, okay? I do not want a sales pitch, all right? And you're not going to get one. Do not request a penalty removal because my teammates are totally wrong about me, okay? And all the data says otherwise, but they're just being mean, all right? That kind of stuff is just shake my head, all right? And it won't work. Okay, expect to receive this email if you do send me a grade grubbing email. It will say exactly this, templated with your name put in the X, okay? Blah, 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 discussed in class, you need well-evidenced rationale in writing, your correspondence does not meet this bar, your overall grade is representative of your performance, blah, 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 I'm not going to change anything, okay? This is the grade, this is the email you're going to get, and I've got so much data that I'm going to send to whoever you try and talk to about this topic after the course is done. Okay, so good luck with that. It never goes your way, all right? Still hasn't yet. 7 years of teaching. All right, if you did a good job in the course, if you've done right by your team, you've got absolutely nothing to fear, okay? Otherwise, you definitely do. Okay, all right, so any questions or comments? Yes?
Are we going to have access to power during the...
Yes, of course, yep. You'll have power. Yeah, we blew out power in the past, but we upgraded the electrical systems in the Beister building, so that's not happened since. We should be fine. Okay, let's finish this course up. Does anyone know who this is? You probably don't know who this is, but you've definitely heard his phrase before. This is George Santayana, kind of a late 1800s writer / poet. He had a phrase, those who cannot remember the past are condemned to repeat it. And this is the kind of thing you often hear in the context of history, right? We want to understand our past so that we can decide what things we want to repeat and what things we definitely don't, okay? But he was really, right, he was probably talking about rulers and societies, how they rise and fall, mistakes that societies make. But what he's really talking about is more generalizable than that. He's talking about the topic of iteration, okay? And it's a really, really, really important topic. This is about more than just game dev. Iteration is something you can use in your life in general, okay? You've invested super heavily in this course. This is not an easy course, okay? You put a ton of time in, much more than many other courses. And so it really makes sense for us to iterate on the course itself, your experience in it, okay? Let's review, reflect, and make a plan for the future. This is the iterative design pattern. You analyze where things are at in your life. You design some sort of tweak or change to hopefully improve things and get to the place you want to be. You then go and execute it, and then you check, did it make things better? Okay, and then you go around the loop more. Okay, this right here is a screenshot of my daily journal. Okay, I have a bot. Every single night, a bot will create a Google document, give it a title, and then email it to me at about 10 p.m. And I can choose to write in there. I just click the link and I start writing, or I choose not to. Okay, and you can see that there were some periods where I was writing almost every day. I was reflecting. How did the day go? How's the week going? What are my objectives for the day, for the rest of the week, for the month? Okay, what's on the horizon? But there were also big stretches in my life where I didn't do this. Okay, and I want you to guess what the most productive moments and stretches in my life tend to be. They tend to be in this section where I'm constantly reviewing and reflecting. It's a lot of time. Okay, a lot of time, because most of these kind of average around 2 pages double-spaced, usually about 30 to 60 minutes of writing. But the decision-making coming out of these stretches tend to be vastly better than the decision-making coming out of these stretches, okay? Much more efficient, okay? I encourage you to log and journal if you can as well. Make it as frictionless as possible, and you'll start to discover that you make better choices, okay? In the same way that I discovered it. Some questions you should always be asking yourself. When you've done something hard, like you finished a course like EECS 494, what did you gain from it? What did you spend to get it? Because sometimes the spend is simply too much, okay? You gain some cool knowledge, that's great, but if it costs too much in time, money, relationships, if it drives you mad to get it, probably wasn't worth it, okay? And then the big question, what comes next? And that's a question you all need to ask yourself soon. Some of you who are graduating have a lot of reflection to do on what comes next, okay? What do you want next from life? My cross-country coach in high school had a great saying I've never forgotten because it's haunting. He said that college is the last time in your life where you're pretty sure you're doing the right thing. After this, it's not really obvious if you're doing the right thing, if you're working the right job, if you're in the right city, okay? It's not obvious if you're with the right person, okay? So anyway, what was gained? Did you gain money? Did you gain knowledge? Did you gain influence? And if so, over what? Influence over something pointless is not so useful. Did you gain relationships? Did you meet people you can work with again in the future? Okay? Did you gain satisfaction? Sometimes it's not about money. Sometimes just that feeling that you've completed something, right? That's very real. Did you gain any joy from your work? Was any of it valuable and how? But then you have to weigh that against how much did it cost, okay? Because I'm guessing you learned a lot in 494, but there's a reason it doesn't have 1,000 people in it, okay? For many people, the cost is just way too steep for this game development knowledge, but for some people, it's worth it. What did you spend to gain whatever you gained? Did you spend money? Oh yeah, in your case, you definitely did, okay? What about stability? Do you feel healthy? Okay, are your relationships still in a good place? Did you sacrifice things you shouldn't have sacrificed? Did you sacrifice your sleep to finish EECS 494? Okay, was it worth a massive time spent? Okay, stress. All right, all the hair you lost. Okay, for me, it was definitely worth it, by the way. And it's definitely worth it grinding to create new courses like 298. The feeling I get when it's finished is just incredible. But you have to ask yourself that question, okay? You might not want to have the 494 experience ever again, but maybe you will, okay? And maybe there's a way you could get it, but at a better cost. You could be more efficient. What comes next? Would you do whatever you just did again, okay? Would you iterate again? Was it worth it? Could you make tweaks to make it worth it? Maybe you went through 494 and you just had a lot of bad habits. But if you did it again, it would have been much better. Maybe, maybe not. Who could you work for now with whatever skills or knowledge or relationships you just gained? How could you improve unrelated work now? Okay, these are iterative questions that are deeply personal. Everyone will probably have a slightly different answer, okay? But it's important that you ask yourself these questions. And don't just do it for EECS 494. When you go to that first job, okay, and that first anniversary is finished, you should ask yourself these questions. Are you happy? What are you getting? What are you spending? Is it worth it? Can you make it worth it? Or do you need to move? You need to try something else, okay? This is how you iterate in the real world. This is also how you iterate video games, okay? But you can iterate anything, and that's what's really important. What you've gained in this course, it is helpful to review. A couple of these things are no longer applicable, but you learned a lot about Unity, okay? One of the reasons people take this course is they want to become not just familiar with Unity, but quite good at Unity. And I think many of you very much are now. You learned about the basics of Unity. You learned about composition as a design pattern. Okay, when I was building the main Megs web game, one of the first things I did was I re-implemented the composition design pattern, a basic version of it, in JavaScript, so I could start creating my own rigid body components and giving them to different objects and actors and all that, right? Collisions and triggers, you know the difference. You know why they're valuable. You've learned and gotten a bit more experience with the basics of Jira, right? Which you'll see in industry for sure, managing projects and all that good stuff. Coroutines, version control, okay? Just getting more experience with Git and merging and going through a few repo disasters is a big deal. You know that Git LFS is a thing, probably because lacking it caused a disaster. I just killed one of my repos because I pushed a Blender file of 150 megabytes and I should not have done that last night. And now my 298 repo for all my educational materials is shot. Okay, and now I have to go do that again. Still learning that lesson. Raycasting and game engine basics. You are better at Unreal Engine, despite never having used it, than most people. Okay, because you know Unity, thus you can speak its language even if the dialect is a little bit different. You learned about game design and basics, right? Interesting decisions. You remember that lecture? You learned and studied classic games like Metroid and Zelda. You learned, you re-implemented those games, right? You've written a surprising number, like 10 plus pages of research documents and reflection and all that stuff. We had our big lecture on guiding the player, right? You know that game design is basically education design. You need your players to be learning new things. It's not general chemistry. You're trying to teach them about gameplay mechanics, about enemies, and about what certain things mean in your game, right? You learned about juiciness. You learned a little bit about SIMD and all that other stuff. You got a bunch of play testing done, and you've got hopefully a better feel for how you execute that well. What do you pay attention to, right? How do people, your players, communicate with you? You probably learned a little bit about animation, a tiny bit, and about creating deep and accessible mechanics, right? You remember Getting Over It. We talked about that. Simplicity of the interface, but just depth in the mechanics and the physics and all that. I don't think we talked about business analysis tools. That's an EECS 40 topic. You got a little bit of experience with UI and UX. You built that Toast manager, right? We did that in class together. Okay? Many of you got experience with a freelancer. I'm not even going to ask how those went. I hope it went well. Usually it's hit or miss, okay? Feedback loops. You remember Mario Kart with that negative feedback loop pulling us back to the pack, right? You remember the idle game genre, which is all about positive feedback loops, right? You created trailers, right? Bringing your kind of guidance knowledge from the world of video games to the world of film, okay? It definitely translates, at least a lot of it does. Exhibition techniques and today's SIMD stuff, as well as some professionalism stuff, scene transitions, stuff like that. This is a ton of stuff, okay? And you should all feel really good that you powered through this in just 4 months. Absolutely amazing. And this isn't just engineering knowledge. You are really becoming very well-rounded. You're going to start to have yourself, you're going to notice yourself developing opinions about things you didn't study in college. All right, you're going to look at a game and say, that art style is really great, but I wish that their UI matched it better. You're going to find yourself becoming slowly but surely more of an artist. And definitely, watch out if you take 298 next semester. If you stick around just slightly after lecture, I'll show you one final thing that I think you'll like, especially 298 students. What you've gained is not just knowledge And what you've gained is not just the future of games, right? Your ability to go out and make super cool titles from the AAA to the indie, you've gained knowledge of the entire future because games are becoming fundamental and core to everything that deals with technology, okay? This is not just the world of crusty terminals anymore. Lots of those still around, they're great, but people expect richness from their software these days. They expect enjoyment. Juice has to show up in operating systems, okay? Right? You've got your visualizations for research. You've got online communities. You've got Nike building visualizations and tools to sell more shoes, okay? It's ridiculous, okay? This stuff is everywhere. You've got medicine and pediatric medical care, right? Using Unity and game dev to calm down their young patients, okay? Plan your wedding, yeah, that can be done with game dev, okay? Research, genetic algorithms. One of the coolest things for a researcher to do is go create a really cool piece of software to like be able to capture screenshots and data, right, for papers and stuff like that. Labs love that stuff. Laboratories love you, okay? My biggest problem is they don't know about you. Okay, so I have to try and connect to the dots here and get you opportunities. Don't sleep on those lab and educational and academic opportunities, okay? Game dev for research. You remember all this stuff, right? NVIDIA can't afford to get permits to have their autonomous vehicles driving around with their software. So what do? They go into Unreal Engine and they build a virtual city. And they have their algorithms run on a virtual car there where they don't need permits. And if they make a mistake, no one gets hurt. Amazing. Absolutely amazing. Okay. Visualization. You remember Bride View, plan your weddings, right? This thing, I made several $1,000s building a social media visualizer application, right? Gwydion, this is a chemistry molecule visualization. Use virtual reality. It's much more immersive. It's much more accurate than a 2D image on a page. And so you make fewer mistakes. For humanity, right? Using game dev for things like Spellbound, pediatric medical care. Mainichi. Did we do the games and art lecture this semester? I don't think we did. That was 440, okay? This is a game in which you step into the shoes of someone in San Francisco with a very unique identity. It's a game she made to help her friends understand the unique challenges she faces. Google Mainichi, play that game if you want to. Games for education, Minecraft, okay? Oregon Trail, all that good stuff, helping people learn faster. And once you've taken this course, you're never going to create a slideshow with a slide like this again. Why? Because you know the golden rule of teaching is, are they going to read the manual? No, they're not going to read the manual. They're not going to read the docs for your API either, by the way. Okay, so you need to design things very carefully. Okay, if you ever end up building a physical experience, whether it's a cheesy Halloween show, or whether it's a theme park at Disney, this will all come in handy, all right? I'm going to show you this clip during the showcase. But Steve Jobs knew all of this many decades ago, which is why the Mac operating system is juicy and so pleasant and pleasing, okay? And I'm going to show you this on Tuesday, but you're going to have to wait and see. You're really going to love it, okay? You're going to love it. Simulation, right? There's a lot of simulation that looks like this, but more and more simulations, training, education looks like this, okay? And there are a lot of defense industries around the world who will pay you lots of money if you are down with the ethical stuff to build simulators for fighter jets or for tanks or for whatever. Lots of stuff for first responder training as well. You take EECS 440, you get a lot of experience with that. But the key to it all is iteration, okay? And that is the main takeaway of this course, okay? Here are the 3 that I would ask you to keep in mind. You have become more than an engineer this semester. Hopefully you've discovered that not just engineering and programming, but art and design and music, okay, and writing and narrative. All of these beautiful fields have an endless amount of things you can discover. You've spent 4 years becoming great engineers, but you can spend your entire life becoming excellent at the other stuff, and I hope you will. It's a very, very satisfying way to live, okay? Gives you a lot of purpose. You're just constantly learning new things. Okay, and by the way, please take it easy on artists and all these other disciplines. They have a very difficult, very challenging technical life and field too. Okay, no disrespect for these other disciplines. Iteration can solve and help you work on any problem you have in life, not just in your games, okay? You want to get bigger, you want to get buffer, then go iterate your gym routine, okay? Go iterate your financial situation, your job, your application process, okay? Remember, you don't have to be in a good spot, and you don't have to get everything done tomorrow, right? You just need to make sure things are getting slightly better day by day. And then some days they get worse, but then they keep getting better again, okay? That's what iteration does. It frees you. You don't have to be nervous about what's going on anymore. You eventually get to where you want to go. Life is long if you don't waste it, okay? But it's very short if you do. Confidence with feedback. It still hurts when I read the evals at the end of the semester and I hear that a student had a bad time. Okay, it's not my goal. It's not why I'm in this job. Okay, if I just wanted money, I'd be anywhere else. All right, and by the way, that goes for anyone else teaching in this department. Okay, anyone in this department can triple their salary overnight if they leave. We're not really here for that, and that goes for all of your professors. All right. When you get nasty feedback that you didn't want to get, all right, treat it as the gift that it is. Feedback is a gift. Remember our very first lecture? Remember Scott Cawthon? He was so hurt when people hated his animatronics, right? But then he realized, wait a second, I can turn this into Five Nights at Freddy's. People are afraid of my characters, so let's lean into that, all right? And the feedback was the greatest gift. It wasn't a painful thing. Sometimes feedback is trash. It's not very useful, but still someone put in the effort and time to give it to you. So we treat it as a gift and we moved on, okay? In any case, it might never get easy for you to receive negative feedback. It's still not for me. It's still very painful, but the pain goes away. Give it a few days. The pain goes away with time, and you're left with something very useful, usually, okay? So hang in there and don't give up. 2 final notes and we're out of here. Goodhart's law. Any observed statistical irregularity will tend to collapse once pressure is applied to it for control surfaces. What does that mean? It means when a measure becomes a target, it ceases to be a good measure. Here's what I mean about this. This is what has been constraining and guiding your efforts in game design for a long time in this course. Interesting decisions, novelty, iteration, professionalism, okay? Ask yourself, how would Flappy Bird score on P3 in this course? It would get obliterated. One of the most popular, beloved games in history would not get a good grade in this course. Okay? Why? Okay? Ask yourself about games like Gone Home, kind of a walking sim, not a lot of decisions to make, very narrative focused, would not do well in this course. Okay? And yet both of these games had a huge impact, very popular games. Okay? This is to say that do not let EECS 494 constrain your creativity anymore. Okay? You are free. And the only reason I have this rubric is because we somehow have to take an infinite creative space and we have to kind of mush it down into something that can be objectively, semi-objectively, and semi-consistently graded. That's the only reason I have a rubric. I'd love to get rid of it if I could. But here's the thing. Go leave this course and do something weird. Make the least novel game that's ever been made. Okay? And maybe you have a huge impact because you did something so you broke so many rules, right? And that's another thing. Matsuo Basho, a famous Japanese poet, if you go, I think, to Osaka, you can find a hill to climb that has a lot of his sayings. And as you climb up the hill, you see even more of them, all right? And this is something that the Marty O'Donnell, who did the Halo music, told to us at the North American Video Game Music Conference when it came to Michigan. If you keep climbing this hill, you'll find one of his phrases that really resonated with Marty, and it resonates with me as well, okay? Here's what it said. Do not follow in the footsteps of the wise. Instead, seek what they sought, okay? Because I know some ways to design games, and they're pretty good ways to design games, but I don't know everything. The leaders of this industry don't know everything, okay? And the next great game design is not going to be found by following their rules. You cannot take a course to find the next great game design, okay? That blows everything else out of the water. You have to go out there. You have to seek greatness, okay? But don't necessarily follow our footsteps, okay? Keep an eye on them. They might be useful, but you don't have to follow our path, all right? I've taught you everything I know in this course, but there are lots of things I don't know, okay? And that's where you come in, all right? You got to find them, all right? And whatever you do, keep iterating whatever you do, and that will give you hope for the future, optimism for the future, all right? Thank you all so much for joining me in this course. It's been a pleasure. You are all amazing. You're so hardworking. You're geniuses. You don't get enough credit, okay? When you get the bad grade in this course, reminder, this course is the ultra hard course that everyone's afraid to take, okay? And any bad grade you get in this course, you would have gotten an S+ grade at other universities. Don't tell them I said that, okay? Don't tell them I said that. But thank you so much, all of you. I really appreciate it. We have one final thing to do. This is 30 seconds, I promise, and then you're out of here. What do you get at the end of a awesome dungeon? You get course completion sticker. Congratulations, you all did it. Well done. Please, before you leave, come up and get one of the more exclusive and hard to get stickers in our department, okay? Congratulations to all of you, and I will hang around for just about 5 more minutes, and I will see you at the showcase, okay? Take care, everyone, and bye-bye. And everyone online, I'll see you later as well. Take care, all. Bye-bye.